right. Hopefully, I am heard and seen. Um, Welcome to TGIK. I want to make sure that I am heard and seen and not just talking to the void. I'm going to look to make sure that folks can see me. Look for a thumbs up somewhere. So hopefully you can see me. My name is Vladimir Vivien. Um, I'm with VMware. I'm an engineer at VMware. And this is my TGIK. This is my first time hosting it. So hopefully it'll be special. It'll be fun. And today we'll be talking about Crafty. And I'm not going to get into the details right now. But if you're here, you either want to hear about Crafty or you want to see my beautiful face. Either way, welcome. Let me check out actually, let me do this. Let me share my screen to make sure that we can get screen sharing going. All right, yep, we're gonna share. Let's see, we're gonna share application window. Let's share second screen. All right, okay, so yes. Hopefully you can still see. All right. Okay. So I think, let me see. All right. All right. So forgive me. We're using StreamYard, and I'm a little unfamiliar with StreamYard, but I think I can get it to work. Actually, let me stop saying. Let me make sure I just share everything to make sure that we are seeing. You guys are seeing whatever I'm seeing. Okay, we're gonna do screen share. All right. So welcome again. Once again, my name is Vladimir, and I am. All right. So hopefully you're seeing the episode notes. And again, we're going to talk about crash diagnostics today, or crash D. So as the host, I believe I'm supposed to do weekend review. Actually, I want to make sure. Let me stop the screen sharing. Let's see if I can see comments here. No comments, huh? Okay. StreamYard doesn't show me the comments. So here's what I'm going to do. I am going to launch YouTube. And I'm going to see. I'm going to see if I can see it from there. Anyway, hang tight, folks. We still 3 minutes after, so I'll get everything set up, and then we will keep going. But I want to make sure that I acknowledge folks as they come in. And I thought StreamYard had a chat window, but I'm not seeing it here. But hang on. Let's see. So I'm going to launch YouTube. And let's see. Yep, here's YouTube. All right, now I got to quiet YouTube, so I'm not. All right, awesome. Now I can see. Awesome. All right, I see from my YouTube window, I see folks trickling in. Hello, Joe. Hey, man. Excited to see you too. Hello, looking forward to this episode. Awesome, from Waleed. Sevi, hi. TGIK, happy from Istanbul. Let's see, who do we have? Sevi, hi. Michael Klug, hi. Loud and clear, Joe. Okay, awesome. And Joe, I thought there was a way to see the comments in StreamYard, but I don't see it actually. Oh, I see. Oh, all right. I got it now. Sorry, folks. Getting used to the UI. Okay. So I see my comments in my comments in StreamYard, and I'm going to kill YouTube so we're not eating up resources. Hello, everyone. Yes, I see my StreamYard comments. All right. Okay, so we're 6 after. So let's keep going. I see folks keep trickling in. Hello from Helsinki, Juka. Hopefully I said your name right. Noel. Glad it started. Yes. Somebody, who's this? Robert. Hi. From Germany. Awesome, awesome, awesome. All these folks come to check TGI to check the show out. All right, cool. So again, my name is Vladimir. I am from VMware, and today I will be your host for the TGIK show. And as I said earlier, if you're here, you probably want to hear about Crafty, and we'll get to that. But before we do, let me go ahead and share my screen. And yeah, it's the problem with this is when I leave the tab, I lose everything. Okay, so you should be seeing my show notes, but if not, I will check. Let me check. Please let me know if you're seeing if you see my show notes whenever I move from the tab. All right, come on. Yep, show notes visible. Awesome. There's a little lag from when for the comments to come in. All right, so let's do a weekend review. Kubernetes 1.21 was released, so I'm pretty sure it's a lot of work went into this release, just like any other release of Kubernetes. It's a lot of work, and we have a lot of dedicated folks to help out. So please check it out. So if you have the link to the show notes, you should be able to click on it and read about the release. Two big deprecations, and thank you to Lori and Joe who helped me with the show notes. But two big deprecations were announced. PSPs finally are on the chopping block, and then topology keys. And again, if you want to learn more, take a look at the notes. And then also CRI tools was released with the 1.21 release. For 1.2, if you're interested in joining the release team, it's a great way to be involved upstream and join a ton of fun. And yeah, but it's hard work, but it's super rewarding. So if you're interested, this is the link to the application. Again, open the show note and you can jump directly there. Also, a guide for Kubernetes networking. Let's see what I did not take a look at this. Let's see what we got. Open a new tab. And this is from Kevin Sukachev, and it's a guide to Kubernetes networking model. I'm pretty sure this will come in handy for folks who are interested in learning more about Kubernetes networking model. So anyway, if you're interested, check out the show notes and take a look. Let me jump on the StreamYard to make sure things are going okay. Zoom in a bit. Okay, awesome. Let's see. All right. You know what? I think I'm gonna keep the YouTube going because that's the only way for me to know what's going on. All right. Let's keep going. Cisco's intern system modeling approach. I'm guessing this is a. Let's see what this is. This is probably a blog. Yes, it is a blog by Dominique Torno. Oh, this is not a recent one, but I'm pretty sure if it's on the notes, it's probably useful. Again, it has to do with networking and networking policies, etc. So go ahead and check that out. Survey of chaos engineering tools for Kates. I think that I remember seeing this. I believe it's also a blog. Let's take a look real quick. There you go. So open source solution for chaos engineering, which we know chaos engineering is becoming very popular as a way to make sure that you have a reliable cluster. So this is a blog from Vasily Marner from Flint. So it looks like a pretty lengthy write-up. So I'm pretty sure there's some good informative tidbits in there. So take a look at this blog about open source solution for chaos engineering in Kubernetes. All right, let's keep moving down the line. Why I run Django on Kubernetes? That's a good question. Let's see. Why do I want to run Django on Kubernetes? So this one is from, who is this from? Anthony Simon. I just read the name from the URL. Let's see. It looks like a good write-up why Kubernetes is the right spot to run Django. And if you're not familiar with Django, I believe it's a framework for Python to create web framework. I think it's a web framework for Python. So anyway, if you want to learn about why Anthony Simon is using Django and Python, please take a look at this write-up. It looks very, very informative. Cool. Let me see if there's any comments. Let's see. Yes, Waleed, I think Crafty and Chaos probably is a good pair. And I think Waleed also said, this is a recent tweet from Tim Hawkins, Cisco intern. All right. Okay, cool. All right, let's get back to the notes. Yes, I did. It's a Cisco intern. I don't know if it's a Cisco intern who wrote it or, Cisco interns, system modeling, sorry. All right. Okay. And then from this last one from Nova, I'm pretty sure it's maybe Chris. I'm not sure. Let's see if somebody could. Yes, it is from Chris Nova. Awesome. And this is about the distributed operating system void. Thoughts on missing parts at the node level below Kubernetes land. This sounds very interesting. Let's take a look. Yes, it is Chris. All right. This was a recent one, actually. Cool. I will be typing this in proper capitalized English, unlike my image. IP is accredited to concepts proposed by Andrew Reinhardt. Cool. And this, again, looks like a pretty lengthy paper. about distributed system and what's missing in Kubernetes. So I'm not going to sit here and have you watch me read the paper. You are welcome to, and that's why we have the show notes, so we can share these links with you, so you folks can go out there and check out these beautiful write-ups that folks in the community put together. All right, let's see what else we have. That's the end of the show note. Let me go back to the stream to see if I have. Man, I don't know how to get rid of this. All right, so somebody on the chat has clarified what the write-up is all about. Cool. All right, folks. I don't think there's any other questions or anything else I see on the chat. So again, this is my first time doing this, so I'm just gonna go with the flow. I think at this point it is a good time to get started and introduce Crafty. But before I do that, let me go ahead and open YouTube. All right, I never did open it earlier. So that way I can see. All right, cool. I can see what's going on because when I move away from my StreamYard tab, I have no idea what other folks are seeing. All right, awesome. And yes, I can see the writing is so what's going on here is the fact that I'm on a large monitor and it's like stretched out, so it comes out a little small on your side. All right, so we're done with the show notes, and like I said, I don't think I saw any questions or anything outstanding, so I am going to keep going. I'm going to keep going, and we will start talking about Crafty. Awesome. So, Crafty, as I put in the show notes, and I am the lead on Crafty, and Crafty is a project that started about a year and a half, almost 2 years now ago, and it was immediately as an open source project, and basically the need was for us to have a way to allow folks to extract information from to automate the extraction of information from a cluster for the purpose of diagnosing issues, troubleshooting, etc. So if you go back and look at the GitHub repo for Crafty and go way back, you'll see what Crafty used to look like. And then about a year ago, we decided to switch from what it used to be, more of a line by line, kind of like more declarative approach. That's what it used to be. But now, a year ago, we decided to switch and adopt the Starlark language. And Starlark is a dialect of Python. And basically, it allows you to write code just like Python. And you can execute that code using a runtime within Go. Starlark has runtime in many different other languages, but since Crafty is written in Go, we went with a Starlark Go implementation. And today we're going to talk about what that has allowed us to do. We're going to look at examples of why a tool like Crafty is important in the supportability of your cluster, how you can use it to implement diagnostics type features in your Kubernetes workflow. And also, if we have time, we'll talk about what Crafty could be, because as you'll realize, the fact that Crafty's primary use today is automation for diagnostics, but it could be something that we keep working on and iterate on and make it even more general in the future. So we'll see. We'll talk about all of that. I'm just taking a quick look at the comments here to make sure I'm all right. Cool. So we talked about all this. So let's go. I think I may already have. Actually, let's close some of these tabs here. Okay. Yep, don't want to close the StreamYard tab. Cool. So this is, let me make sure this is being shown. Yes. We'll kind of blow it up a little bit. All right. Awesome. Maybe that's too big, but that works. So this is the website or the repo for Crafty. Crash Diagnostics is the long name that was initially selected. And basically, if we scroll down, we see the different features that are part of Crafty. And basically, as we'll see in a minute, as we start going through some of the actual scripting, it's like I said, it's based on Starlark. It allows you to automate interaction between your infrastructure that's running Kubernetes. You can do interaction via SSH to target your compute resources, or we can also use constructs that talks to the API server to extract information from the cluster as well. And there's also support for cluster API. I don't know if I may or may not have time to talk about that, but we'll see. And how does it work? Well, Crafty is a single. It's a single binary basically. When you build it, it gives you a single binary, and basically you just point that binary at a Crafty script or a Starlark script, and it'll just go ahead and execute everything in that script. All right, so we won't go over the installation, but what's in that script? Well, this is what the script looks like, and we'll go back and actually work on some examples so you can see how it works. But just at a high level, this is what the scripting for Crafty looks like. There are several different constructs. One type of constructs is for configuration, and this is what this is doing here. We're creating a configuration. Basically, the configuration is something that collects settings for something. In this case, the setting is for Crafty itself. And here we're also using a different type of construct. Actually, there's several type of constructs going on here. And we'll disassemble that when we look at an actual example a little bit later. But we see that we have resources, and we have a provider, and then so the resource takes a provider, and that's what we're doing here. And then the provider can take a list of hosts, and it takes what we call another configuration. And that's what we're doing here. Again, we'll disassemble that in a little bit later. And once you have your resource, in this instance, what the provider does, it allows you to enumerate your resources. And in this instance, the resource is basically compute resources. And it enumerates those compute resources so that we can apply operations on those resources. So that is, at a high level, that's pretty much how Crafty works and does everything. So you have something that can enumerate resources, and then you have configuration, you have resource enumeration, and you have operation that can be applied to those resources. So now that at this point we have our resources enumerated when we store them in hosts, and then now we can do those operations and apply those operations against the resources that were enumerated. So CrashD comes with several, I should say, it's a few operations that you can apply to your resources, and we'll look at that, what those operations are. Here we're using a function called capture, and basically what capture does, it allows you to execute a function on a remote compute resource, and then captures the output of that command. So here we have several capture commands, and what's happening is the command that's specified here is being executed against each enumerated resource, compute resource. So for each capture command that you see here, it goes through the number of machines that were enumerated and attempt to execute that command against that machine one by one. Now, CrashD, I'll just throw that as a side note. CrashD is fairly nascent project. There's a lot of work to be done, and I know one of the places I want to get to soon is the ability to do parallelize a lot of these operations. Now, today, when you hit a resource, it serially go through each machine and execute the command and then gather the result. But one can imagine a future enhancement would be to write, to update CrashD to where each machine gets executed in its own in its own execution thread, and then gather the result after each command gets executed. Anyway, that was a little side note. And then toward the end, one of the functions that we have in CrashD is something called an archive, and basically what it allows you to do is to specify. So one thing I should point out is that as CrashD execute command, a lot of the commands that CrashD execute returns some sort of result, like for instance capture. And as we capture these results, they're stored locally. And what we could do is use archive to basically grab these local resources and bundle that into like into a tar.gz file. Okay, so at a super high level, hopefully that kind of gives you an idea what CrashD is at a super high level. Let me check to see if we have any kind of questions. All right, Joe, I think that her thinking CrashD might be related to. Let's see. Okay, yes, Chris Nova. I'm not sure. Did I miss COSI? COSI? I'm not sure what that is. All right. Anyway, so it doesn't look like Flux is amazing. It's interesting. All right. What if the API server is the one having issues? Okay. I'm guessing this is probably a question for me. Yes. I mean, if that was directed for what I was talking about, yes, you can talk to an API server, and we'll go through. Oh, okay. Thank you. Wally just clarified that COSI has to do with Chris Nova's post. Do you set CrashD in proactive mode? This is from Waleed. Or is it after an issue? That's a very interesting question. So basically the question is, do you set CrashD in proactive mode where it's watching your cluster or your infrastructure, or do you react post a problem? Right now, the main use is when actually, one of the driving reasons why we started the project is we wanted a tool to help us diagnose clusters as they were being created, and folks run into issues, and we wanted something that helps us debug whatever those issues are. So today, the primary usage model of Crafty is after something has happened, then you go against the cluster and you extract information so you can do your analysis. But because as you could, actually, I don't think I've shown how you run Crafty, so let's do that here. This is how you run Crafty. It's a simple binary one command, and you pass it the script. So I'm showing that to say you could wrap Crafty in any kind of deployment model that you choose. So you could take Crafty, throw it against a cluster itself. Now, obviously, if that cluster goes down, you want to be outside the cluster to be able to diagnose it. But if you want Crafty to be, nothing could stop Crafty from running within a cluster. And you write your script in such a way where it intermittently go through and do things and collect data and generate that the report that we'll see that gets generated at the end. So, and there's a lot of usage ideas that can come out of Crafty, and because one of the things we wanted to do is keep it simple, keep the way that you use Crafty very simplistic, even as a consumable programmatic API. I wanted to make sure that it is very super simple to consume Crafty and keep it super go-gettable to where you can include it in your own tooling. So we want to make sure that it is super useful, super usable in different contexts that we can't even imagine right now. So long answer to a simple question, but yeah, right now it's more reactionary than it's proactionary. All right, let's see if there's any more question. This kind of looked like Apple System Diagnostics, maybe. You mentioned that you're getting your event from the API server or CAPI. Yeah, you can get you can extract information from the API server. I haven't gotten to that. I haven't shown an example of that, but it'll come later. Just we'll see that in a few minutes. So Conware asked, is it collecting data using API server, or is it LS? Is it getting information by running native OS commands? So it's doing both. It can do both. We can, there's a set of commands. Actually, let's do this. Let me go to, where's it? Here it is. Let's go to the docs real quick, because there's a lot of question about usage. All right, so there's a doc that I try to keep with, basically it's like a reference to all the commands and everything else that's included in Crafty scripting. So let's take a quick look at what's available. Let me make sure this is not super large. Okay, it looks good. Again, we have different examples in the doc, but here are the let's see, Crafty script file. So this is talking about what the script file is. So let's actually, before I dive into, no, actually this one only do OS commands. Eventually we'll get to the one that does, we'll get to one that does both. But this basically is showing you an example of how you can create your own functions, because again, it is a Python dialect. One of the things you can do is create your own function to basically localize your own logic and then reuse that logic as you see fit. So this guy is basically it's doing the enumeration of machines using the host file. This is just an example, and basically it uses the host file, use grep, and use the run local to basically, as the name implies, runs the command locally, grab the result, use string dot split lines, which is a built-in functions in Starlark, and then we take that and uses that as for our provider so that we can do our own enumeration of resources, and then we can use that to connect to it. So this is just to show you an example of what's possible. But anyway, let's keep going. We have so we have configuration function. Man, this is kind of big, so it's going to take forever to scroll down. Let me kind of move it down a little bit. Okay, maybe too small. All right. Let's see. Wait, there you go. Okay, so so this one is these are the configuration functions I had mentioned earlier. So you have crash config, which basically allows you to configure crashd itself. We won't stay and read everything, but I just wanted to show you what's there. We have kubeconfig. So for all the questions about can you talk to the API server? Yes, you can talk to the API server. Kubeconfig allow you to configure when you use path to tell it where your kubeconfig file is located. And if you use CAPI, you could provide it a CAPI provider, and we'll see what a CAPI provider is later down this document. Okay, and here's an example of what a kubeconfig looks like. Args, I haven't talked about argument passing, but you can pass arguments to your script and reference it in this manner. SSH config, we've seen example of SSH config where you can configure SSH and then use it later in other commands. Let's see. Here's an example of SSH config. We've seen that before. Now, provider functions, and that's what I had mentioned earlier. What is a provider is something that allows you to do enumeration of your infrastructure resources. Right now, it's compute resources, but in the future, it could be more than that. So we have a Kappa provider, which knows about Kappa, which is the cluster API. Kappa is the cluster API provider for AWS. And it knows how to enumerate machines when those machines are running within a cluster API initiated cluster running on AWS. Okay, so that's that. And here's an example of how that is used. So what you see here is we declare our Kappa, well, actually, we declare SSH config. So if you have keys, if you want to talk to machines that are part of your Kappa cluster, and you want to run commands directly on those machines to extract information, and because that will be done over SSH, first you have to declare your SSH config. Hopefully you have access to the proper private key to do that, and then we specify a kubeconfig because we need the kubeconfig path, and then we declare the Kappa provider. Now, once you have, again, as we've seen earlier, once you have a provider, the provider can be plopped into a resource, and then that resource can enumerate whatever the provider has to offer. And then we have a CapV. CapV is for clusters that are hosted within vSphere. Again, it's for cluster API hosted clusters that are running on vSphere. So same type of idea as we've seen with a Kappa provider. We see that we use it in a similar fashion. Hostless provider is the one that we saw at the very beginning. It's basically something that as a script author, I can explicitly provide the host in the code, or as we saw earlier in this in the example earlier, you can write code that generate that list for you. So hostless provider is one of the simplest provider. And here's an example here where we specify the host explicitly. And then once we can enumerate our compute resource, then we can apply operations on those resources. Let's see. All right. So, and then we have a KubeNodes provider. As the name implied, the KubeNodes provider is a generic Kubernetes provider. And what it allows us to do is to figure out node information using Kubernetes and using the kubeconfig that we have. So what it does, it talks to the API server, enumerate the list of nodes, and take that and parses it and makes the IP address or the node name available so that we can talk to those nodes and apply some kind of command against those nodes. All right, let's keep going real quick. And then resources is what takes all your providers and enumerate the resources so that we can apply a function or a method. So this is an example of all three types working together. So we have an SSH config. Now we have the resource. We have the hostless provider. We've seen this. This is the same example we saw earlier. But the way resources and providers works similarly for all the other type of providers. So the same model imply. You would do something very similar for other types of providers. And then once you have your resources, then you can apply an operation against that resource. Hopefully that makes sense. I'm going to take a pause right now, check to see if there are any questions going on to make sure I'm not missing anything. All right, let's see. Crib. Hey, YMO from Canada. Let's see. Red Hat OpenShift uses must gather. It runs on a node, and I guess okay. Yeah, I would imagine there are other similar tools out there. But one of the things we wanted to do with Crafty too is to make sure that if you do not have a cluster operational, you could still run Crafty. And it can still be useful because a lot of times, sometimes when folks are setting up, especially day zero or pre-day zero, when folks are setting up their cluster and something funky happens where you don't even get to the cluster being installed or forming. But you're still interested in talking to those machines and see what happens. If you even got to your VMs standing up. If you have VMs standing up, a lot of time those VMs, they gather a lot of valuable information if there's something funky going on. So what you can do is use Crafty to talk to get OS level information even before your cluster is fully formed. Let's see. Yes, Darwin. Yes, Darwin and Linux binary are available. All right, Joe clarifies something. Yeah, the idea is to have a flexible, super simple way. Yep. Why is SSH config needed when we are giving kubeconfig? So we use in kubeconfig. The reason why we need SSH config is sometimes sometimes the the node information is already encapsulated in as part of your node information in your cluster. So you can use the API server. You can query the API server to get that information rather than you having explicitly specify that information. And we need the SSH config because we use that information to SSH onto the node and do OS level operations, like we've seen, like for instance, run a command on that machine. And before we get to that point, we need information. So it's two ways you can get that machine information. You could explicitly specify it, as we're seeing here on the screen, or if you already have a cluster that's so fully formed, but you want to get that information from the cluster. And this is very important in the case of like a cluster API, where you can have a guest cluster, for instance, that's being hosted by a management cluster, that was deployed by a management cluster. You could query the management cluster for machine information about the guest cluster and grab that information from the API server, and then still be able to do OS level operation against those compute resources that are hosting the guest cluster. Hopefully that made sense. I'm gonna look at the questions to see if there are any more questions like that. Is it capable of parsing the output of CMD or just capture in a file? That's a very interesting question. Yes. So it's two commands that we have. So as you, hopefully you can see, so we have the run command, and we'll talk about, actually we write here in command functions, we could talk about the command functions. And the command functions are what we use to actually apply commands either locally on the machine where we're running Crafty, or remotely on the compute nodes or compute resources that we're interested in. And yes, so when you do run will run against your machine and actually return it'll return whatever the response was, and then you are at liberty to do whatever you want with that result. So that result will come back as a string, and we'll see an actual example of that. But capture skips that step and automatically grab the result and stuck it in a file for you. And by default, the file will be named based on the command, but you can specify an actual file name if you want. And so let's go through real quick through the command functions, and then we're going to look at actual, because I'm kind of paying attention to the time to make sure we don't run too long. And then we'll take a look at actual scripts and work through some issues, work through those scripts. So archive, we see what archives, we've already seen what archive does. It basically is it's a function that runs locally, and it takes a group of directory or files and bundle that into a tar file. Capture, we've already talked about capture. Capture does exactly what it says. It'll run a command on a remote machine and captures the result automatically into a file. And you could see that you could specify a file name, but by default, it'll use a string for the command to name the file. What else we got? Actually, here's an example. It's basically the same kind of example we've seen. Let's keep going. So we have capture local. So this is something we added later. Capture local does exactly what it sounds like. I didn't want to overload the meaning of capture, so I created a new function that clearly states what it's doing. So it basically runs locally and captures information from a command that is executed locally and put that into a file. And let's see. And then we have copy from. Copy from is exactly what it sounds like. It allows you to copy a file from the remote compute resource onto your local machine. And here we have run. So run is what you use to run command against your remote machine. And it does the command and return a string as a result. And this is showing you this silly example of running. I think it's running up the, where is it? I don't see it. Oh, the uptime command on the remote machine. And then we have run local, which basically does exactly the same, but on the local machine. All right. And then this is what I really wanted to get to, the Kubernetes functions. So you have kube capture. So before I even get into the Kubernetes function, today, most of the, actually, I think all of them, what they do is they query the API server and you get a result back. You can, with kube capture, it'll take that result and save that in a structured directory layout and put the result there to avoid clashes. Okay, I will highlight the output. And then, so that's pretty much how the kube underscore commands, that's how they work. There's a kube capture, there's also a kube get. But let's see. So kube capture allows you to query the API server and capture information from the API server. Let's look at an example so we can see. So here, so we declare a kube config. We create a namespace list of what we're interested in, and then we say kube capture. Now the watt parameter basically specify what is it that you want to capture, and then namespace, and then kube config, and that's pretty much it. So you could capture logs or objects. Let's see what else I can show real quick. Oh, well, we also have the notion of default values, and we have something called, okay. So we have something called set default. There are different type of configuration that you can set as default, and we use the set default function to do that. Once it's set as default, you don't have to necessarily specify it over and over again. And this example is showing that being done with resources here. Once we set that, we see that we set that as a default, and then we don't have to down here, we don't have to specify that. It's a nicety, a little bit of magic, but it's there to allow you to make your script look as simply as possible, because the scripts can get big. Okay. We have OS constructs where we have access to os.name, which return the name of the OS username, OS home, and you can also extract out local get, local environment. Arguments you can pass. So two ways you could pass argument, either in a file or --args. And basically --args is just a key value pair that you pass to your script. Okay, so that is a high level of the script. I'm gonna look at the comments to see if there's anything going on, and then when we come back from the comment, because we're already rolling into the 1 hour mark, then we're gonna start looking at actual scripts and run them locally on my machine, and debug stuff as we go through it. Okay, so it would be nice if it does pre-flight check, after updates, upgrade, pre-validation check. All right, let's see, runs. Okay, yeah, you guys are coming up with some interesting ideas. Got it, as in playbooks, okay. Okay, so why not Ansible? The already as modules and can interact with the Kubernetes API. Yeah, I mean, that's a valid question. Why not Ansible? I think this is super lightweight. At least that's one of my argument is it's lightweight, it's programmable, it's consumable as an API. That's another thing. You can wrap it in different mode of deployment. I could put everything in Crafty inside of a Docker file, or run it directly locally. There's no need for anything else other than the Crafty binary. No other there's no agent that needs to be deployed. I'm pretty sure if I sit here and kind of think about it, I can come up with a more reason. But obviously, if you're in a shop where Ansible works for you, then obviously that's what you should use. But Crafty, I think, adds another dimension to the to the conversation of supportability. All right, let's see. If you have not already, can you talk about how you can debug Crafty itself? Yeah. Okay. Yeah. So I see what the question is from YMO. How do you debug the Crafty script itself? So one of the things I do, actually, I don't have my Goland running, but I'm not going to open it. One thing I do is I turn on the Python. I know it's cheating. I turn on the Python, the Python plugin in Golang to make sure that it gives me color highlighting. That's one thing. Two, yes, you can do, you can put print statement all over the place, or print function in your script to get to kind of output things as your script is running. You certainly can do that. As far as debug in the traditional sense, I don't think there's anything like that where you can step through, or at least I haven't seen it. I haven't looked at the Starlark project in a while to see what things they've included lately, but I don't think they have anything where you can do any step through debugging. But that would be an interesting thing to look into, to actually, debug, start your debugger from Go and then have it call a script file and then continue that debugging as things are getting executed by the interpreter inside Go. There's nothing like that I know of. So yeah. Other ways you can debug. Yeah, definitely, print statement is a big one. What I was gonna add is the Starlark runtime is decent at giving you good errors. Not not all the time, but most of the time it's decent. Some can appear a little cryptic, but if you know in what context the error happened, you can a lot of time figure out what's happening. Because sometimes you'll get something very cryptic and it turns out a value was nil or something, or it was expecting a value, but it's empty. But instead of saying that, it says something completely different. But again, if you know, and that's where the print statements help, you can analyze your script with print statements and kind of narrow down where your errors are happening. All right, let's see if there's anything else. Yes, yeah. Okay, yes, I am. Hopefully, we'll get to the point where we can run things in parallel and make it. So, actually, one thing I should say, Crafty is open source and it's available under the Tanzu open source banner. But it is, it's not something that I'm doing for fun. It's actually something that we use a lot internally. It's part of CI/CD pipelines. It's used in a lot of it's also used a lot with Sonoboy, which I'm also the lead of. And folks use those two tools in different contexts, but a lot of time you'll see, especially in our build pipelines, you'll see folks use Sonoboy to kick off some kind of conformance test, and then at the end of the pipeline, if there's anything funky happen, they'll also kick off Crafty to go around and collect information in the pipeline. We also use Crafty as part of our product as well. So it's something that we're definitely serious about, and it's not, like I said, it's not something that it's definitely a fun project to work on, but it has some serious usage and as part of the Tanzu portfolio. All right. Okay, so let me grab a swig of water because I've been talking for almost an hour now. All right, so now what we're gonna do is let's look at some examples. Where are my examples? All right, let me make sure that you all can see my screen. Okay, cool. So yes, you are able to see my VS Code screen. So what I'm gonna do though is split screen with, let me split screen it with my terminal instead of using the terminal inside. All right, let's do this. Or am I? Let's close this. All right, let's do this. Just so we can have two things going on. All this real estate, we should be able to see multiple things at the same time. Okay, so the first, let's look at some examples, and I kind of highlighted these examples in the show notes, but I don't know how closely I'm going to follow the show notes. Let's see what happens. Okay, the first example, let's look at this example, and we'll go over it, and hopefully it'll make sense, and we'll try to run it. So locally, I have a Minikube cluster running. Let me make sure my Minikube cluster is still running. Where am I? All right, so I still have my Minikube cluster running, and it has 3 nodes. Let's see. Yeah, it has 3 nodes. It's just a plain cluster. There's not a whole lot running on it. Oh, and in case you're wondering what this tool is, I'm just gonna plug in my other thing that I work on. This tool is part of is just me. It's called KTop. It's also it's under my personal GitHub, but it's something that I rarely have time to work on. But when I do, I add features very slowly. But basically what it is just KTop, as the name suggests. It's top for Kubernetes. And here we're looking at my nodes, and you could see, so how rough around the edges is KTop? Look and see that this whole panel empty, nothing in it. But it does the job for today. So it shows me that I have three. It shows me that I have three nodes, and there's some pods. And actually, this is from kubesystem. All right, so we have a Kubernetes system Kubernetes cluster running. Let's look at this this script. All right, so we have SSH. So basically, we have SSH configuration. Now, the one thing I didn't realize about Minikube, when it sets up, and I don't know if you can change that, but basically when it sets up when it sets up your cluster, each node gets a different private key. So I had a longer example, but I had to basically shorten it to only talk to one node, because the SSH config, I can only put one key in there. And so right now I'm only using it to talk to one machine. But anyway, so we have the host list provider. I don't know, is this good enough, or maybe I should let's do it one more. All right, that's good enough. Okay, so yeah, there we go. So we have the provider, as we've seen. This is the list provider with its IP address, and then the SSH config is being referenced here. Anyway, we've seen this example before, so let's go ahead. And what I'm doing is run this command on this resource. And I think I forgot who asked the question, but I could have done here. I could have captured the result and save it in a file, but I'm using the run function to execute my command, and then I do what and then I can reuse the result however I see fit. And in this example, I'm just printing out what the result is. So let's go ahead and run this. Let's see, where am I? Okay, this is kind of small. Let's wait for it. There we go. That's not what I meant to do, but okay. So let's go ahead and run this. All right, so this example won't do much other than talk to the first, I think it's the control plane node, and grab the uptime information from it. So let's go ahead and give it a try. So actually, it's because the Crafty binary is up in the previous directory. And then run, and then the name of the, and we'll put a debug here so we can see what's going on. All right, so here it is. That was the Crafty running the script, and this is the print statement that we have at the bottom. That's what it's doing. Now, I wanted to show you this. Ooh. Oh, okay. Yeah, I wanted to show you this. So uptime, what run returns is a what we call a Starlark struct. Actually, if you have more than one machine in that list, it'll return you an array of structs. But since it's only one, it's going to return you one struct. It might be a behavior that I change later, but right now that's what it is. I thought I was being slick and helpful, but when I thought about it, and I kind of got confused earlier, I'm like, wait a minute. I thought this was an array, and I was like, oh yeah, I remember. I was being helpful with a feature that no one asked for, and yeah, and that was throwing me off. So hopefully, when I get around to it, everything will be uniform. You'll always get an array. So if you print uptime, I just wanted to show that real quick. You'll see what all comes back. So here it's printing the actual struct. It's called command result, and it has an error. If you want to check that, it has the resource that it talked to, and the actual result as a string that came from the result of the command. All right. Okay, so let me check questions before I move to the next example. Let's see. Okay. Yes. So there's we're still talking about Ansible. Yes, Starlark is super flexible. Cool. All right. So looks like there's no question directly about what we just looked at. So we'll look at another example. Let's look at example 2. And pretty much most of these we kind of covered before, but I just wanted to show them running. All right, let's look at this guy. Okay, so we already talked about pretty much everything in here. So one of the thing, well, what this is doing, what this example is doing, it's using Cube Capture to talk to the API server to pull logs from this namespace, Cube system, and we'll see how it does that. So we configure crash D. We set where we have the notion of a working directory, so we set that as being directly at the location where we're running the script. We set our kube config, which to point to the default kube config location. So you can imagine that being anywhere. And then we configure our kube capture, saying we want to pull logs from our API server. And then once we're done, we wrap everything in a tar file. All right, so let's run this real quick. Let's see what the let's see. Capture. All right, so it is done. Now let's see what it created. Let me make sure that I'm not too small on the font. I think it's okay. All right, so here's the work directory that it that it created as it's collecting information, and this is the tar file that it generated. So if you look in the working directory, actually, let's do it from here, so it'll be quicker. If you look in the work dir, you'll see what came back. And basically, it does something similar to what kubectl does with the cluster info dump. I don't remember the name of the command exactly. But basically, it arranged the result in directory names that matches the resource where the result is from. So we targeted the cube system, the cube system namespace. So it creates a directory cube system, and then inside there, all objects that we queried are captured here. So for instance, here we see, I don't know, some of, yep, there you go. So this is the log from that particular pod, and you can see logs from other pods, etc. So that's how that works. So all that information is basically wrapped up into the tar file that was generated. All right. So that was that again. That's something we've already seen. So let's go somewhere to something we haven't talked about. Let's see. I think capture. Oh, this one. Actually, we talked about this as well too, but it's more this one. It's so this particular example. Let me close this. let's go real quick over it. But it's basically doing the exact same thing that all the other examples are doing. We set up some configurations. We set up a provider, resources, SSH config. Now, basically what I'm doing here is embedding the definition for the configuration directly in as part of the parameter for the enclosing function. So here we're putting SSH config inside the hostless provider, and then we're putting hostless provider inside resources, and everything is just enclosed in. But it's basically the same thing we've done before. We're declaring an SSH config, some kind of provider, and then pass that to our resources. And then once that's done, we execute capture command against it and archive everything that was captured. So if we run this, let's see, example 3. All right, so let's run this. All right. And you'll see some warning because it probably was unable to actually some errors too, because I think it tried to talk to something it couldn't talk to, one of the machines, I believe. So anyway, so here is the result. So, oh yeah, this is what I wanted to show. The result and how it's captured. Let's see, if we look here. So remember I was saying how by default the capture command will create files that uses the name of the command as the name of the command, or the string for the command as the name for the file. So that's what's being done here. But you can override that behavior by specifying an actual command or an actual file name. So you can come here and say file name equals, I don't know, sudo.txt, or actually df, that's more like it, txt. Then if you run this again, and obviously put in a comma, and if you run this again, you will get, the capture will now use file name df to generate the to generate the file. All right, let's once again, let me take a look at the comments to make sure I'm not missing out on the fun. All right, what else can you pull other than logs? Any resource event? Yes. So that was from Waleed. Yes, you can pull just so the code behind kube capture and kubeget. We're not going to get into kubeget, but kubeget is basically kube capture without. It basically returns a structure, an in-memory structure that you can use in your script. But both of them use the same code internally. It's the same Go code, and what that allows you to do is basically query any resource that's inside the API server, as long as you provide it with resource name, path, etc. And then it'll figure out how to get to that resource and return either the full resource dump for you. Yes, let's see. Starlark. Skylark book a long time ago. Okay. Did you picture a centralized library of capture script for diverse type of scenario, e.g. check network? Yeah. Actually, that's a good question, Waleed. Yeah, it would be nice eventually to have pre-baked and tested, I guess, scripts that can be reused. One of the things I haven't done, because you can do it in Starlark, but I haven't done it in as part of Crafty script is the ability to actually create modules in Starlark and have those modules be reused. So one could imagine having a collection of scripts that does different diverse type of scenarios, like networking, like control plane, like very specific type checks or pulling information for diverse type of resources. Could we variabilize script? Yes, you can. I'll show that in a second. Let me see here. Yeah, curated script. Exactly. That's the name I'm looking for. Yeah, you can variabilize your script. You can variabilize a script from the outside. Actually, let's do that now. We're approaching 5:30. Actually, I'm doing a time check on you guys. If you want to keep going, I can keep going. Otherwise, we can wrap up in the next 5-10 minutes. But before we do, let me do because I think that's one thing I have not talked about is the ability to variabilize your or parameterize your script. So let's take this script for example. I think this one it ran without an issue. Let's say let's find something. Okay, let's take this guy, the host. Okay, awesome. Thank you for the feedback, Waleed. So let's take this guy for instance. I'm gonna copy it. I'm just gonna copy it. So I'm gonna do args.ipaddr, for instance, right? All right. So now what I can do, this is capture CRSH. Let's come here. Let's blow away the worker and I don't want to do that in diagnostic script. Okay, so let's remove those. Anyway, so what I wanted to show is this. What we can do is come here and say args equal space. What did I call it? IP underscore. So you can say IP underscore ADDR equals. Oops, sorry. We don't need all that. We just need this. All right. So conceivably, it should. I can't remember if I need to quote it or not, but we'll see. If it works, then no quotes needed. If it doesn't, then we'll figure out quotes. All right, let's run this. All right. So this is the kind of errors that you get when you run your script, and it's very Python-esque. And you get basically a trace back, a stack trace rather of your error. And it's telling me that crash the config host parameter got a string. I want a list. Yeah. Sorry, that was my bad. Let's put it as a list. Okay. Let's try that again. There you go. So we got the same result. So this was just to show you that you can parameterize your script. Actually, there's another way we can do it. I'm going to do it now too, so you can see. All right, so the other way you can parameterize. So this one was with the args flag, but there's also args file. So if you have a bunch of these things, we can come here and I didn't mean to rerun it, but let's wait for it to finish. All right. Let's create a file called args.txt, for instance. And we're gonna, in that file, we're gonna put this, And then we're going to get out of that. And we're going to run. But instead of args, it's going to be args file. And then the file name args.txt, I think it was called. And it should work. Yeah, there you go. So a couple ways you can very astute, very interesting question, because you're an astute observer, YMO. Right now, what happens? So the question is, what happens if the args was missing? Right now, the script will fail. So one of the things, I think I have an issue where it fails badly, actually. Actually, let's do it. Let's change it to IP. So if you do that, yeah, it is. And basically, it just says that I don't know. There's no IP attribute that you specify. One other thing I want to do is kind of rework that argument section to where it doesn't, because there's some instances you don't want that catastrophic failure just because somebody didn't pass an argument. You may want to recover, or because this is more of a parsing failure, not necessarily executing failure, not a logic failure, right? So, as it's parsing or the internal structs, it sees that it doesn't have an IP attribute for that particular struct, then it fails. But there are instances where you don't want that failure. You want something else to happen. Maybe you want to test instead of you want to test for that particular value instead of outright failing. So that's something that that's in the pipeline as an issue to fix for to have a way to gracefully recover when an attribute is, or when an argument is not provided. Yes, that's actually so YML points out that Bash has a way to specify default values. Yes, that is one way of approaching this as a fix, is to provide. So we could provide a default value if none is provided. But the problem is the data or the type that's used, Starlark structure. If it doesn't see, if it wasn't constructed ahead of time with that particular attribute, then it complains. So having a default value probably will help, but I'm thinking that there might be some additional work that needs to be done with that. Okay, so let's see something. Yes. Yeah, actually, I haven't looked into Starlark embedded set. Oh, I see what you're saying. Yeah, to set default. Yeah, actually, funny enough, one thing I was considering is how Go does flags parsing. One thing I was considering is do something flaggish, for lack of a better term, where you pass the flags. I mean, you consider the incoming argument as flags, and you provide something that describes each flag and what you should expect. I guess that kind of plays into the suggestion to use default. But you declare your expected arguments ahead of time, and then let Starlark figure out and what to do when the argument is not there, so that if you pass something completely unexpected, it'll do something like this where it completely crash. But if you pass something that is expected, then you can test it. Even if it wasn't provided by the user, then you can test it and get around the catastrophic failure that it does today. All right. Let me see if there's anything else. Let's take a look at the show notes. I think we've looked at, yeah, somebody put KTOP on there. Awesome. Let's see. I'm trying to think of what. Oh, so the one thing we haven't talked about that I think we did talk about it is look. Sorry. So we talked about the hostless provider. I don't know if we ever talked about the Kubernetes, the Kubernetes provider. Well, actually, we did. No, we did not. This is just a kubeconfig. So the Kubernetes provider, I was just checking out the question that I saw pop up on the side of my head. Is it hard to extend Crafty and add custom functions? Okay, so it is not hard. Matter of fact, let's take a look. It's a good question. So the question is it hard to extend Crafty and add custom functions? So the answer to that, no, it is not hard. But it also depends on what you're doing and how you want that custom function to behave. If you want a built-in custom function, then what you have to do, let me go back to top here to the code so you can see how that works. Let's go to the Starlark directory and let's take archive, for instance. So if you're extending Crafty itself via Go, Starlark gives you a function type called a built-in that you have to, let me make sure that you guys can see this and it's not too small. Yeah, it's kind of small. So this function is a type, implements, has a signature for what we call the Starlark built-in function. And when you implement a function with this signature, then that function can be registered to respond to a script function call. And I'll show you how that's done. So here we have archive func. It takes some arguments, and there are examples of what to do with these arguments. But these are basically the arguments that comes from the script, and you get them here, and then you can parse them, and then now you're in Go territory, and then you can do Go as you do normally. And then once you're done, you can return a value back to the script, which is what we're doing here. But that value has to be a Starlark value type. Here we're returning a Starlark string, which has the path of the generated tar file. Okay, so that's one step. And then what you have to do once you have your function, you have to come here. I got to make sure I remember where that's at. I think it's here. And then you have to register. Here we go. So here, when you call the Starlark method, I think it's function or method. I don't remember which one. But basically, once you instantiate the script so that it can run, you have to pass what we call a string dictionary, and basically it's basically a map that has the name of the function in the script associated with the actual Go function that is to be called when that function in the script is encountered. So for instance, we just looked at archive. So archive, let's see. So archive, uh, that identifiers that archive is basically resolves to a string. And then that string is now the name of the script function that will be, that when it is encountered, will be executing archive func, which we saw earlier. So that is at a super high level how you extend on the Go side. Now on the Starlark side, on the script side, that's another way you could extend Crafty, because what you can do is create functions. I think we saw examples of function. Did I? No, you know what? We did not. But I'll go back to a Starlark function. So yeah, so let's look at a Starlark function. The one that I like, because where is it? It's in docs. Okay, this one right here. Okay. So you can use the def keyword just like in Python to declare and define a function, a high level function. And then once you have that, you can use that function in your code. Now, one thing, like I had mentioned that earlier, Starlark supports the notion of modules. So what you can do is create a collection of Starlark scripts, and each one of those scripts could be a collection of functions, and then store that close to Crafty, and then you can have like you can have like a main script that uses those modules as needed. So that's another avenue of extension that you can use. So I wanted to point that out. Okay, hopefully that made sense. Let me check. Let me check any questions that you all may have. All right. Other than the GitHub repo, is there any other resources? Slack channels? Yes. Yes, actually, there is a Slack channel. Let me see if I can get it. It is. So, yeah, there's a Slack channel. If you go in, if you're in the right now, actually, it's not used much, but right now there is one in under the Kubernetes Slack, and it's just crash dash diagnostics. We'll put it in the show notes as well. Like I said, it's usually the interaction. The interaction is it's either over Twitter or internally or via GitHub. But if you guys want to reach out on Slack as well, please do so, because we're trying to, that's one of the reasons why I wanted to do this TGIK, is to talk about Starlark and basically be loud about it and let folks know that it's out there. What we want to do. Awesome, Waleed. I see you. Awesome. Thank you. And let folks know that what we're doing with it, and eventually I'd like to keep working on it and make it an awesome tools. I have tons of ideas that I'd like to see hopefully get into I'd like to see get into the projects. As I mentioned earlier, today the use case is definitely supportability, and I think I forgot the term that Joe used, but what I'd like to see eventually is more and more functionalities added via the function, to where the way that we interact with the cluster is more general. So it's, if we have resources, we'll move faster. If not, it's those two hands, whenever time permits, to get on there and work on it. But this, I think it's time to to wrap up, because I'm starting to run out of gas. Um, Thank you, Joe. And But yeah, this has been fun. This has been joyous. Extremely humble to be able to share the stuff that I've worked on for the last, like I say, year and a half. And hopefully after this, this community exposure will get more traction in the community and have folks participate. As the participation goes up, as interest goes up, I can go back to my manager and say, "Hey, look, man, we need more folks. We need more more resources to get to make things happen." But even as something that I do with countless other things that I'm involved in, it is very, very rewarding to work on this project, because it's something that came from not existing to being part of being distributed with our products, being open source, being used heavily internally. So super humble to have had this opportunity to work on it, and look forward for participation from you. And I'm checking to see if there's any more question. Awesome. Thank you all for participating, for coming by. I think I'm going to call it quits. It's 41 after 5, so I've probably been talking for about hour and 45 minutes now. So I'm going to go ahead and end the transmission. So again, thank you, and hopefully I get to do another one of these if I can talk Joe into let me drive this car again. Awesome. Thank you. See you next time. I am ending the broadcast. Bye-bye.